Hello and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of equations and inequalities. This is standard 7.11a in the great state of Texas, and we are using item number 28 off the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got this scale balance here, and it represents an equation. And so we can go ahead and put an equal sign here. What we need to do is we need to kind of transfer this into just number form here. So when you see all of these ones and these x's, right, the only thing this can really represent is addition. So we're going to add on the left side, right? I've got x plus x plus x. Then I've got 6 ones, right? So I can do plus 1 plus 1 plus 1, and then 3 more times. Now, we could do that, or you realize you can just count by ones and go 1, 2, 3, 4, 5, 6. I've got 6 ones. So we can do that. Let's go ahead and do that for our right side, right? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9 ones. So what we could do is we need to go ahead and do that for this right here. We need to make this 6. And we need to collapse these 3 x's right here. So what we could do is we could just count how many x's we have. We've got 1, 2, 3, right? So it is 3x. So that's how we can represent multiplication, is we can say this is 3 times x, or just 3x, because there's repeated addition. And that's what multiplication is a way of looking. And there's no negatives here. Sometimes they'll give you a key and they might say that negative ones are shaded in or something like that, but there's no negatives here. All right. So we finally have our equation. 3x plus 6 equals 9. And let's see, we need to isolate our variable. We're going to use our order of operations in reverse, because that is, we always start with the weakest connections or the weakest links to that x, and addition and subtraction are the weakest. We try to get rid of those first, and I've got an addition right here, a plus 6. So the inverse operation of addition is going to be subtraction. So in order to get rid of my plus 6, I'm going to subtract 6 from both sides. Plus 6 minus 6 gets rid of itself. 9 minus 6 equals 3. So what I've done here, we can actually visualize it since we've got this nice picture here, is I took away 6 from both sides. Let me just get rid of these 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Since these 6 are all equal to 6 ones, I can take both off of each side and know that I still have a balanced equation. So take a look. I've got 3 x's over here, and I've got 3 ones over here. Well, you could probably just visualize this to see what it is, but we'll go ahead and go through the operations. We have this 3x, which is really 3 times x. Anytime you see a number next to a letter and there's no operation shown, it's going to be multiplication. Just because we multiply so much, it's just easier just to infer it. And so the inverse operation of multiplication is division. So instead of multiplying by 3, we're going to divide by 3. That's going to cancel itself out into a 1. So we're going to do 3 divided by 3. So x equals 1. Now, that might seem pretty simplistic, but take a look. Look what's left here after I take away 6 from each side. I've got 3 x's and I've got 3 ones, and they're equal. They're still balanced. Well, the only thing that it could really be are 3 ones. Any other value would be unbalanced, since there's the same quantity on both sides of this balanced equation. So these 3 ones plus these 6 ones make 9, and this make 9. So it does make sense. We did all that work, and x is equal to 1. Our answer here is J.